Okay, so we're going to start talking about piecewise functions today. So up on the screen I have for you just an example of one. Basically it's a function that's broken into pieces. That's really all it is. So I have, in this particular example, I have one function that's happening here. I'm assuming that goes on forever. So from negative infinity up until negative 2, my function follows this path. But then, once I go past negative 2 all the way up to 3, now I'm following along this path. And then, once I go past 3, I'm following along this path. Okay, so we use piecewise functions all the time, whether you know it or not. So, for example, think of parking at an airport, right? There's certain, if you park in the garage and you're there from, I'm just making up these numbers, I don't have an exact example in my head, but next time you go to the airport, pay attention. It'll be like, okay, if you're here from, 0 to 3 hours, we're going to charge you this rate. If you're there past 3 hours, we're going to charge you this rate. And then there's even long-term parking, where if you're there past 24 hours, they charge you a different rate. So you would be following different paths depending on the length of time that you're there for. Does that kind of make sense? So things like that would represent, it's, there's only one fee that you're paying, but it changes depending on how long you stay. All right? So that's kind of what they look, they could look like anything, but I just think of it literally as functions broken into pieces. And I'm just following a different path depending on where I am in my domain. Okay? So if we look at what I gave you here, this is typically how we write them. So I have my function f, and this one's being broken up into two parts. So I'm going to follow this when x is less than or equal to negative 2, and I'm going to follow this when x is greater than negative 2. Notice that there's no overlap here, right? There can't be, because remember what a function is. If I plug in a value for x, I can only get one value back out for y. So I can't have any overlap here. So this region over here just kind of tells you where you are in your domain. And this first part tells you what the function's going to look like. Does that kind of make sense? All right, so let's try some of these. Down here, I'm asking you to evaluate the function at these different values. So you're just going to take negative 4 and you're going to plug it in for x, right? I get kids that do this all the time. They take negative 4 and then they plug it in here, they get an answer, and they plug it in here and they get an answer, and then they give me two answers. Ay caramba, that's violating everything that a function is. When I plug negative 4 in, I can only get one answer back out. Only one. You can't get two. If you look back at this one, if I want to know what the value of this function is when x equals 1, right? I go to 1. Okay, so the value of this function would be, I don't know, maybe a third. If I want to know the value of this function when x equals negative 3. Oh, I get out a 3, don't I? If I want to plug in positive 3. There are not two values for positive 3, right? That's open, which means that the answer for positive 3 would be negative 1. Do you see that? There's nowhere in here, no matter what I plug in for x, I'm never going to get two y values back out. Do you see that? If I did, it would not be a function. So when I go to plug in a value here, I can't plug it into both of these. That would make no sense. That's why I look here. Remember, my function lives here when x is less than or equal to negative 2. If x is greater than negative 2, then my function lives here. So I need to look at the number that I'm plugging in, negative 4 in this case. Well, is negative 4 less than or equal to negative 2? Yes, it is. So when I go to plug in negative 4, it's going to live here. I would never plug in negative 4 down here because this part of the function doesn't even exist until x is greater than negative 2. And that's not where I'm at. Does that make sense? So my function only exists at negative 4 up here. So I'm going to plug in negative 4 to the top. So when I do that, that would be 2 times negative 4 plus 4. What do I get out? Negative 4. So the value of my function at negative 4 just so happens to be negative 4. Okay, now I want to plug in negative 2 itself. So again, you always start over here and figure out, well, which of these two does negative 2 fit into? The top or the bottom? The top again, right? It does not fit down here. Negative 2 is not greater than negative 2, so I can't plug it in down here. I'm going to plug it in the top again. So then I go over here and I say, okay, so I'm going to do 2 times negative 2 plus 4. And this time I get out 0. All right, let's plug in f of 0. Where does that live, the top or the bottom? Bottom this time, because 0 is greater than negative 2, so I'm going to plug it in here. And when I do that, I get out negative 4. And lastly, f of 3 on the bottom, so I'd get 3 squared minus 4, which is 5. Okay, cool. Now, I want to try and sketch this. Let's see how we do. We do have 4 points already. So, I mean, we already did the math, so I might as well just throw them on there. If I didn't have them, I probably wouldn't bother, but I know at negative 4, I'm going to get out a negative 4. Whoops. So I'll just put a dot there. I know at negative 2, I'm going to get out a 0. 0, I'm going to get out a negative 4. And 3, I'm going to get out a 5. Okay, again, I don't normally put those dots in, but we have them, so we might as well throw them in. So if I'm going to sketch a piecewise function, what I normally like to do is figure out where my graph is changing. Where am I changing from, oops, like in this other example, where is it changing from this function to this function to this one, right? So my graph changes at negative 2, doesn't it? Negative 2 is where I switch from this one to this one. So me personally, this is not part of my graph, but I just like to sketch a little, I'm going to give myself a little dashed line at negative 2, so I just kind of remember, hey, this is where things change, is right there. I know it's a little hard to see on the screen. Maybe I'll use a little. So does that show up better? Not really. Sorry. Okay, I'll make it big. So again, this is not part of my graph. It's just helping me visualize. On this side, I'm going to have one part of my graph, and then over here is where it's going to switch to the other. So now, let's look. I need to graph. What's that going to look like? First of all, 2x plus 4. What is that? It's a line, right? That's just a straight line. So I'm just going to graph the line 2x plus 4, but I'm only going to draw it when x is less than or equal to negative 2. So how would you normally graph this? Where do you normally start to graph this line? Yeah, I'd start at 4 and then I'd go up 2 over 1. So, sure. I'd start at 4 and then I would normally go up 2 over 1. Now, but remember, my graph doesn't even live over here. It only exists over here. So what I can do is, instead of just drawing it in this direction, how about we just draw it? I would start it at 4, right? Instead of going up 2 over 1, let's go down 2, back 1. But I'm still not over on this side yet. So let's go down 2, back 1 again. Down 2, back 1. Down 2, back 1. Oh, look. And then I only draw my graph on this side. Now let me ask you this question. When my graph hits negative 2, should that be an open circle or a closed circle in this case? Should be closed, because this line does exist when x is equal to negative 2. So I would have a closed dot right there. So that means when I graph this one, wherever it hits my dividing line is going to have an open dot because it's not equal to -2 there. Does that make sense? Okay, what does the graph x squared minus 4 look like? That's a parabola. Do you remember how to graph this one? Well, you guys, you know 1, 3, 5, right? When you're graphing parabolas? Or no? No? So you start at your vertex and you go up 1, up 3, up 5? Yeah? Okay. All right. So where's my vertex for this guy? X squared minus 4 would be at... Oh dear. How do you find vertex of a parabola? Negative b over 2a? Remember? Yeah? What's b in this case? Oh dear. Maybe we need a refresher on graphing quadratics. Remember a, b, and c? A quadratic? A is 1 in this case, b is 0, c is -4. No? Oh dear. Okay. All right. So scratch this. All right. Right. Okay, fine. Let's just plug in some values. We already have a couple points, right? I have one there. I have another one here. Let's plug in -2. Oh, we already did. No, we didn't. Plug in -2. What would you get out? 0. So when my graph hits this green line, it's going to hit it at 0. So if there wasn't already a closed dot there, I would have an open dot. If 2 dots overlap and one's open and one's closed, it just stays closed. So if this had hit somewhere else, like let's say we plugged it in -2 and we got out 3, I would have had an open dot at 3 and then I would keep going. It just so happens that this open dot overlaps my closed dot. Okay, that's fine. Plug in -1, what comes out? -3. So -1, -3. Plug in 0, we already have it. Plug in +1, what comes out? If you plug in +1, right here, what comes out? -3. +1 comes out of -3. And let's plug in 2, what comes out? Yes. And now hopefully you can see our parabola has taken form. It goes like this. I don't need to keep going because it's just going to be off my grid. So, yes, you can plug in all the values. What I was hoping you guys would remember parent functions, like graphing just y equals x squared? And then that -4 just takes the whole thing and drops it down 4 units? Is this ringing a bell somewhere in there? Okay. I will post a video on graphing parabolas. So if you feel like you need a refresher, maybe you could check that out. Anyway, let's try another one, shall we? All right, flip it over. Let's see what we got. Ooh, this one is broken up into 3 parts. So I'm going to have 3 changes in here. First, let's find some values. Yep. On this side? Oh, I think I have a typo. Thank you. That should just be a +2. Change that to a positive 2. Good catch. Thank you. I used to have whiteout up here. Positive. Okay, so let's try this. If I plug in -2 for x, where am I going? Top, middle, or bottom? The top. That's the one where it fits into. So, what would f of -2 be? Just 2, right? Because I want -2. So I get 2. F of 0. Where does that plug in? In the middle. So this is just a constant, right? That just means my answer is just going to be -3. And then if I plug in +2, now that we fixed it, that's going to go into the bottom one, and that answer would be 5. Okay, where does my graph change? At what x values? Yes. -2 and +2. That's where the changes are happening. So I'm going to go ahead and just draw myself. Again, this is not part of the graph. You don't need to do this. I just find it helpful to visualize at -2 and at +2. That's where I'm going to have my changes. So the top is going to exist only over here when x is less than or equal to -2. The middle is only going to exist in the middle, in between these two, in between -2 and +2. And then 2x plus 1 will only exist over here. All right, so if I'm going to graph y equals -x, wouldn't you normally start at 0 and then just follow the slope down 1/1? Yeah, here's another option that if you could do that, but then you're gonna only graph your graph over here, right? You're not gonna graph it anywhere over here. You can also plug in the point where it splits and then find that point and follow the slope from there. So in other words, if I plug in -2, I already know what I get out, +2. So -2, +2. Should this be an open or a closed dot right here? Closed, because my top function does exist when x is -2. So, and isn't this top thing, by the way, it's just a straight line, right? So to graph a line, don't I just need a point and a slope? I have a point, and I know what the slope is, right? The slope is just -1. So I don't have to start on the y-intercept. I could just start here and follow my slope. Again, I would normally go down 1/1, but I can't do that, right? Because my equation doesn't live here. It only lives this way. So let's just go up and back 1 instead. Does that make sense? Do you see that? And then I'll just connect it right here. So then I just verify, okay, do I really have y equals -x that's living only where x is less than or equal to -2? Yes, that is what I have drawn. I'm pretty happy so far. Now, in the middle, in between 2 and -2, I'm really graphing y equals -3. What does that even look like? It's a horizontal line at -3. Exactly. So I'm just going to draw a horizontal line at -3 in between x values of -2 to +2. Now what happens when I hit my two dotted lines? In this case, they're both open circles because it doesn't actually exist at -2 and 2. So it's going to look like this. Open circle, straight across, open circle. Does that make sense? So there's just a constant rate in between those two values. Make sure that your endpoints are open And then I can tell that they're open. Sometimes you make an open circle so small that I don't know what it is. Okay, and now let's graph this other one, 2x plus 1. So again, you can graph like you normally would, start at 1 and go up 2 over 1 if you want, or go ahead and take 2 and plug it in, which we already have, 2 comma 5, 1, 2, 3, 4, 5. And then is this going to be a closed dot or an open dot? Closed. So now I have a point on that line, and then I could just follow the slope, which is kind of annoying because it's already off my graph, but I would go up 2 over 1, so. That would be what that part looks like, even though we're a little bit off. Does that make sense? Okay, so piecewise functions have pieces. Another thing you should do when you finish your graph, make sure just do your vertical line test. I cannot tell you how many kids they do this. They'll graph it, like they'll graph this one the wrong way. So they'll have like this going in this way and they won't have this part. I don't know, because they get all mixed up in their brain. But if they just went and did the vertical line test, they'd be like, oh, that can't be right. So you'll catch yourself, hopefully, if you just take half a second and just double check. Make sure that you don't have 2 closed dots on top of each other, because that can't be, right? Because then it's not a function anymore. Now it's broken. Someone's got to be open. Okay, so let's stop this before I lose it.